Okay, welcome everyone to OWASP London chapter. Thanks everyone who managed to make it to this wonderful venue, to Olympia London. I believe there are still, if you haven't managed to get some food and drink, they're at the back, and I think we expect more foods to arrive shortly as well. We are live streaming on YouTube. So hopefully the stream works. I think I've just tested it, which is working. And tonight's meetup is kindly hosted by UK Cyber Week Expo and Conference. Those of you who managed to come here a bit earlier, hopefully managed to go and speak with the vendors exhibiting and also attend some of the talks. If you missed it, it's fine because the show continues tomorrow. So you can still come back tomorrow and check out the show. The food and drink and raffle prize is kindly hosted by Contrast Security. For those of you who don't know me, my name is Stepanyan. I'm OWASP London chapter leader. We also have two other chapter leaders, Andrew Letzer and Sharif Mansour. They're both on the way here, so they should be joining us shortly. If you are going to tweet about tonight's event or put it on LinkedIn or any social media, please do use hashtag OWASP London and mention us, because we're OWASP London on all the different social media networks. Just a quick reminder of OWASP Code of Conduct. We want to make this a nice and welcoming environment, so please be nice and respectful to each other. The agenda for tonight, we had to reshuffle it a little bit. After my update on OWASP news, on the latest OWASP conferences and projects, we're going to have John and Aurélien talking about how to secure apps and APIs in production. Then we're going to have a quick break to flip over to Dinis, who's going to present a GenAI talk, so how to leverage GenAI and graphs to customize and scale your security knowledge. It's going to be awesome. So looking forward to it, because Dinis also recorded a podcast on this. So if you missed it, I highly encourage you to check out the podcast. And the Q&A session, we're going to have a raffle and some prize giving. If you missed the QR code, I will share it very soon again. And just a quick notice to people watching us live on YouTube. Unfortunately, you cannot participate because the prize is a physical prize. So we have the Lego kit here. So you can only win if you are here. And the way it's going to work, once you register, your names will go into the spinning wheel, and then we'll spin the wheel and find out who's going to be the winner of the raffle. We have to vacate this wonderful venue at 8:30 p.m. because that's when it shuts down and the cleaners come in. But we, as always, will go and continue networking and talking if you have the time in the pub called the Hand and Flower, which is just across the road. How many of you are attending this event for the first time? Oh, wow. That's quite a lot of you. I don't know how you found us, so thank you for finding us. To make sure you don't miss the next event, these are all the ways how you can follow us. So first of all, we have the webpage, owas.org/London. We are on Twitter or X, whatever it's called now. We also on Facebook. You can like us on Facebook. We are Meetup, on Eventbrite, on LinkedIn, on Blue Sky. And also you can watch the recordings of all the past talks on our YouTube channel, which is also OWASP London. And this event is currently being live streamed on YouTube as well, and the recording of the talks will be available. So this is the raffle prize for those of you who are in the audience. So if you haven't registered yet, please do scan it. And this same QR code is also at the swag table in the corner. So if you haven't picked up any of the stickers and swag available, please go check it out. And this is the place where you can scan the QR code again to enter your details. Now let's see if it works. I'm going to play a short video, a 1-minute video. What is OWASP? I believe this will work.
OWASP is a nonprofit that stands for the Open Web Application Security Project. OWASP is a community of developers, technologists, and evangelists improving the security of software through tools and resources. OWASP has 100 plus active projects, and new project applications are submitted weekly. Projects are open source and are built by a community of volunteers. people just like you, community and networking. There are hundreds of local chapters worldwide and thousands of members. Meetings are free and open to everyone. They include training, talks, and networking opportunities, education and training. OWASP hosts many events each year. They are a great way to improve your skills, build your professional network, and to learn about new trends in the industry. One of the many ways you can get involved is to become a member. The membership benefits include discounts for events and trainings, your own OWASP email address and Google Workspace access, a vote in our OWASP Global Board elections. And recently, OWASP added a brand new member benefit, access to hands-on application security training through the OWASP Secure Flag Open Platform. Join us and become a member today.
Okay, see, now go to the next slide. So as it was mentioned in the video, there are several member benefits available. Apart from Secure Flag, we have few other partners who are providing benefits. So please do check them out when you become a member. We do have another membership benefit from Checkmarks. It is a secure coding training platform called Code Mashing, which has lots of courses and security tournaments, like a capture the flag kind of system that you can use for your developers for training. So if you join OWASP, you will be able to use these systems. So membership, as previously noted, for individuals, it costs only $50 a year. For students, it's $20 per year. If any of you represent a company, you want to become our corporate supporter, you are more than welcome to come and join us. Please come and speak to me, or you can just go to owas.org/membership and choose a sponsorship package. The OWASP membership benefits were already highlighted in the video, but there's one more benefit that not many people know, something that I do. I have a stash of this OWASP member stickers for your laptop. So if you become a member tonight and show me the confirmation email from Stripe confirming that you've become an OWASP member, you can get an OWASP sticker from me. We are a vendor-neutral community, vendor-neutral nonprofit foundation, but we are supported by a lot of companies, a lot of vendors. I'd like to thank all of them. OWASP London chapter is also quite blessed because we have quite a lot of corporate supporters of our chapter as well. And if you would like your company's logo to appear on these slides and be thanked, please come and speak to me. Also, we have quite a few companies who also sponsor our meetups as well. So these are all the companies who have very kindly provided a meeting space for us to host us. And obviously, can I please have a huge thanks for UK Cyber Week and to Harun who organized this, and to our support Contrast who sponsored food and drinks, and the raffle prize. Now, the news from OWASP, for those of you who are already members, we have a brand new membership system or association management system, and it's called GlueUp. So the GlueUp, as we are configuring it, has some interesting things. So it has like its own community channel where you can talk to other people. You can exchange business cards with our members. You can participate in various groups. And one of the things that we're currently looking to provide with it, also, you can also prove that you're an OWASP member. So we're looking to provide a digital badge for you through the system as well. There will be more support coming for chapters and projects through this system. So that is a brand new thing that we only started in mid-November last year. So there's still a few teething issues that we're working on, but we are already using it for conference registration system. And I will speak about conference in a little bit. There's another benefit, which I do run exclusively for OWASP London. I've created something called Proof of Attendance Protocol NFT. So if you're attending this event, you can get a digital badge right? A digital sticker, a digital certificate of attendance of tonight's event, which is can only be collected from me in person, and it will go into your crypto wallet. So if you don't have a crypto wallet, then we just can get any wallet that supports Ethereum blockchain. One of the simplest wallets that I use, again, no specific recommendation, you can use any wallet, is Trust Wallet. It's free and open source, and it works on both iOS and Android systems. And there is a different digital sticker, digital badge for every meetup. So people who attended before, I think they collected about 17 or 18 of them already. This is the one for tonight, where they have the WASP just in front of the Olympia stage. So again, you can collect this from me. Please come and see me to scan the QR code. We also have an online merch store. There is some merch available there and some stickers. But if you'd like to have an OWASP t-shirt, baseball cap, a hoodie, and some other swag, we have a merchandise store that you can go and order at any of our merch. This way you will support us. Now we have a global OWASP AppSec conference coming up in Europe, in Barcelona. It's going to be the last week of May. If you would like to attend, if you represent the company where you have developers or security engineers to go and learn from all the best minds in the industry, please do start buying tickets. I think the early bird time is already past, but we still have tickets available for this conference. And there is another extra benefit for people who are already registered, because we have a fundraiser t-shirt. So there's a t-shirt which looks like this. It is only available in Barcelona to collect in person. But if you scan and register and say, I want this t-shirt, then when you come to Barcelona, you will be able to pick it up in person. And it is a fundraiser t-shirt, so we ask for a 50 euros donation to get it, because we stopped printing t-shirts for everyone for the environmental concerns. Okay, and then we have another big conference this year. It's going to be first week of November in Washington, DC, and the call for papers is open. If you would like to present a talk at this conference, please do scan the QR code and submit your talk. We would be privileged to see you in Washington, DC if your talk is selected. It's always a great conference. Usually OWASP has 2 conferences in the United States alternating years. Usually we are in Washington, DC and in San Francisco on alternate years. So, for example, next year's Global AppSec USA is going to be in San Francisco, not in Washington. OWASP is known for its open source projects. We have over 250 projects, which are all free and open source. If you're not using them, I encourage you to go and check them out and use them. We have lots of great tools, standards, guidelines that you can use. Everything's free and open source. If you're unaware, we have a great OWASP GenAI project, and these people have been very busy doing things like top 10 vulnerabilities and LLM guidelines, how to implement AI securely in your organization, how to address the threat of deepfakes, for example, if you have this problem. And we have also 2 new guidelines available. One is on agentic AI. It's the next big thing. Everyone's using AI agents, which is quite scary, doing stuff instead of humans. But also, if you are an organization that's trying to do a bit of red teaming of AI, there's also a red teaming guide now available to download. So if you go to genaiOWASP.org, you will be able to download it. Now, before we move on to the main speakers, how to ask questions today, we do have a microphone at the back, but if you could submit questions ahead of time by going to slido.com/OWASP, it would help us to collect questions early during the presentations, and then we'll be able to ask them live. Okay, and with that, I would like to invite on stage Aurélien and John Wood from Contrast. We're going to talk about securing applications and APIs in production. And let's give a huge welcome. All right, I'm going to stop sharing my screen. And Aurélien, if you share your screen, I think that should just work. Yeah, and can I give you a microphone?
I have one.
This is for live stream on YouTube. Remember to collect them.
Okay.
That's for live stream.
Great. Brilliant. That's great. Okay, my name's John Wood, but before I begin, I'm just going to say a little thing about OWASP, especially to the new people who came here. My first ever OWASP event was actually in a pub about 200 meters away from here, I would say 18 or 19 years ago. And at the time, we were meeting in a pub and, well, there's probably 10 or 12 people there. And there's a certain individual there who's here tonight, and it's Dinis Cruz. So if Dinis can actually just quickly stand up, because I want to embarrass him wonderfully. So Dinis has been at the heart of London OWASP for 20 years?
20 years exactly.
20 years. And he has spent so much time at OWASP, and it's been a huge commitment educating the wider world about upset. And I think what I'd really like to do, Dinis, I recognize that, so I want to give you a big round of applause for that. Because the interesting thing with where OWASP goes, so I started attending London OWASP meetings. I then found myself up in Scotland, so I set up the Scottish OWASP group and kickstarted that. And then last year, Aurélien and I were in Barcelona doing another one of these types of talks. You will learn so much about application security through OWASP, and an awful lot more than you probably will in your corporate lives. It's the communication and the talks which you really gain all of that experience here. So anyway, Dinis, thank you very much, and that's sort of on that part. Okay, on with the presentation, or the talk, whatever we're doing tonight. Okay. I'm going to observe an awful lot of the OWASP rules, so this is non-corporate. And I've been in application security since 2005, 2006. I worked for an organization called Fortify Software. So first of all, I now have to apologize for the false positives. It really wasn't meant to be that way. Terribly sorry. But I've seen this industry evolve and all the big changes in it, from static analysis, dynamic analysis, through to maturity models and SCA. And I left the industry about 2 or 3 years ago, kind of just had enough. Couldn't see a way forward. And then I started thinking about, well, what is the next big change happening in application security? Because we haven't solved the problem. And the simple fact is that first age of the technologies which we developed in the early 2000s, the big static analyzers, the SCA, whatever it might be, that's all come to an end. And we need to change because the challenge we're now facing is unprecedented. When we started OWASP, you would have 1 major release a year and 2 dot releases. We're now on hourly, minute, by second releases. So the tools and techniques we used to use are simply ill-suited for that particular future. And what we've been doing, we've been thinking about how we actually change this. How do we actually reimagine the world of application security and break free of those particular shackles? And that's some of the stuff we're going to be talking about today. And we're going to do it in a slightly different way. You don't often see pictures of Africa at OWASP meetings. And what I want to do is just really emphasize what's been happening in the industry. This is an image of an African dusk. And I was in Africa about 25 years ago, sleeping in a really cheap 2-man tent in the middle of a game park, because that's the type of thing you do. Slept all the way through the night, not a problem. Woke up in the morning, unzipped the tent, looked up, great African sky, looked down and went, oh crikey. And what was in front of me was a paw print about that big. Basically, a male lion had come into the camp, had a good look around, sniffed outside the tent door, and then gone. And that's what we're doing in application security. We don't know the threats which are actually out there. I was lucky that night, simple as that. It could have all gone south very, very quickly. And it's the same in our world. There are so many threats out there we're not seeing, and we don't know when we're going to be attacked. We've got to start changing that. We've got to turn that on its head. And one of the biggest problems we have in application security at the moment is that we have too much noise. All the technology is just, crikey, how many more vulnerability reports do we need? How many more CVs do we need? I read something yesterday saying, oh, we now need yet another dashboard. Well, of course we do. And that can then add to the next 10 dashboards we're already not really doing anything about. So we've got to change this around. We've got to look at this noise and go, that doesn't work anymore. How do we actually get the clarity and actually start acting on the signals we're actually seeing? And I would suggest the biggest problem is this problem of context. It's not a technology problem. It's not a human behavioral problem. It's context. And what we need to start doing is looking at how we deliver information which is accurate, relevant, that's a big one, and also is crystal clear. That's the challenge we're facing. And to sort of highlight that challenge, I'm going to introduce you to Big Boy. This is actually on the same day this is the same day as the lion paw print. It was a hell of a day in Africa. So I'm actually walking through the bush with my guide and another local guide. Just as you do, average day, walking up a hill, and we come across this guy, Big Boy. That is a teenage hormonal male elephant who's only got two things on his mind. One is, are you going to become his special friend, or is he going to kill you? It's pretty binary. Oh, and he might want to eat some food. We're in the wrong place at the wrong time, and we've got a curious, aggressive elephant. And what this elephant does, he goes back into the bush, has a bit of a shuffle around, comes out, and does a fake charge. Not a problem. My guide, Anne-Marie, this is her here, literally is going, shoo, go away. I'm 3 meters away going, it's not a bloody dog. It's an elephant. But then the elephant literally goes, well, okay, turns around, goes back into the bush. Okay. 30 seconds later, elephant reappears. This time, it's a more substantial charge. And Anne-Marie is now up in front. Get away, Big Boy. She's put down her weapon because the idea is not to shoot elephants. And he goes back again. I'm thinking, great. But I notice that Anne-Marie, she picks up her weapon, just starts moving back slowly. I think, oh, something's going on. Because then Bad Boy reappears, and there's two sounds I'll never forget. One is when an African elephant bellows before a charge. It is very, very loud and scary. The second sound is when those ears crack back, because that's when the charge is about to happen. What happens then is this information in context. The first piece of information I receive is fantastic. Run. No debate here. Turned around, and I'm running. Next thing I hear is Anne-Marie. This is being live streamed, so we'll do the Disney version, not the version where John swears like a pirate. Is Anne-Marie goes, no, not that way, run down the hill. To which I literally stopped and went, why? God knows why I did it, but that's what I did. And she just looked at me as she was running past with an elephant, now probably about 10 meters away, and she gave me the perfect piece of advice. Run down the hill because elephants can't run down hills. I was down that hill in a millisecond. Bad Boy carried on, we all got to live. That phrase, elephants can't run downhill, is my favorite sentence in the entire English language, because that probably saved my life. But more importantly, it was perfect information in context. It was absolutely relevant. So when you do the work I was doing over there, you go attend a lot of seminars beforehand, and they will give you in nauseating detail via PowerPoint all the things you're meant to do when you're out in the bush. Nobody ever pays any attention to a PowerPoint. But what Anne-Marie did was she gave me highly accurate information, which was highly relevant and delivered very, very clearly, upon which I acted. And that is what I mean about context. But this is what we don't do in application security. We kind of just vomit results back at people and say, good luck, hope it goes well. And this is how we've got to actually start changing things. And the reason why we've got to start changing it, and this actually really annoys me. I don't know if there's any other vendors here. And by the way, Contrast does this, every other vendor. But I picked up 5 of these reports, and they're published every year. It's the state of software security reports, or the state of API security, or the state of SCA. And they're depressing. They're not really pieces of research. They're just more how bad everything is. And it's the typical, 290 days to fix a vulnerability. Only 40% of critical vulnerabilities are fixed. My favorite one is from Black Duck, which says only 5% of applications have no vulnerabilities, to which any developer goes, yeah, but anybody can write 3 lines of code, which is fairly decent. So it's all out of particular scope and scale here. And the thing which really annoys me more about this is that every year it doesn't improve. Or if it does, it's by 0.01%. Remediation is less than 3%. And as outside professionals, you're seeing this every day in your life, in your daily lives, and yet you're being told more and more this is the big problem. And so what we need to do, and the other thing with these reports, which I really don't understand, is that when I look at that and I put on my different head and I start beginning to think like a cyber criminal, you've actually just delivered the playbook to those people. You're now actually saying, or we as an industry are saying, you have 290 days before anything will happen, give or take. And as a hacker, that's not bad. You're also going to tell me there's pretty much a 50-50 chance that vulnerability may or may not be ever fixed. I like these odds. You're giving me all the reasons, and some of the reports actually go into the detail of the types of attacks which are successful, which is even more insane, of going, well, if you use this particular TTP, that's noticed a big rise in attacks and it's led to ABC. You're going, why would we give the playbook to the cyber criminals? And why are we not improving? And instead, what we need to do, like any good sort of innovation, we've got to flip the model on its head. What we're doing at the moment in terms of static scanning, dynamic scanning, all of those tools, they're all great and they all, quite frankly, work really, really well, probably a little bit too well. And we started asking ourselves a different type of question. And that was, why are we scanning from the outside? Why don't we actually start listening from the inside of the application? Imagining actually how and seeing attacks coming in at the code level from inside the application. Even more importantly, tell when the application's under attack, because we're not under attack constantly. Some applications are attacked more than others. Tier 2 and Tier 3 applications are a particular sweet spot at the moment. So this is how we started thinking about it. And we started thinking about runtime technologies and how you can actually start flipping those terrible results we've had for 20 years where we haven't really moved the needle into something a lot more dynamic. And this is the point when Aurélien is now going to go into some more technical detail. Okay, Aurélien, up to you.
Yes, hello, thank you everyone. So just a quick introduction about me. So I'm Aurélien Svevi, I'm solution engineer at Contrast. So 90% of my job is making sure that John is not saying wrong thing about what we do. So you've probably all heard about the analogy of application security, comparing that to an house where you have a door, you have locks, you have windows, and all of those things are a different product. But I think your application layer is way more complicated than an actual house. It's more like an actual city with hundreds or thousands of applications communicating together with different links, and this is constantly changing. And you won't protect your city with just putting a door in front. And basically, your application layer is maybe even more complicated than a city. But we try to secure that with traditional technology, SaaS, DAST, SCA, and WAF. But those tools are not looking at the application itself. Those tools are looking just a part of each of these applications. You will look at the code, you will look at the library, you will look at the HTTP request, but all of that with different product and separately. We don't look at the application, we look at the ingredients. And you know what? You can have very good ingredients and that will do garbage food. I'm not saying that because I'm French and I will have dinner in London tonight, but I have experience with that. And so again, all of those tools are missing some context. And if we want to detect properly vulnerabilities in application, we need some context. So, but how can we do that? And there is clues that exist, and you all know them. And when I will mention that, you will only see that now, and you will always remember those two things. All the other layer of your environment has made a huge shift from scanning to actually behavior analysis. We had this discussion 10 years back about EDR. You had this discussion with your colleague saying, well, I have this antivirus, but I know this pretty weird technology, which is called EDR, doing some weird thing on my laptop. I will never install that. Do you imagine now not having EDR on your application? You won't. And that's exactly the same shit. You are doing a behavior analysis. And also, EDR is just an example. You have all the DR that could exist in your environment. And when you speak with AppSec people, they will all tell you that they want those contexts. They want to know which vulnerability is actually exploited. They want to get all of those contexts of what is the potential impact of this vulnerability. I have 10,000 vulnerabilities, but which one is actually the one that will kill my application? And the answer is in production. All of those information are actually in production. Because in production, that's where you actually have your actual application running with all the exact links to all the different parts of your application, to your subcontractors, or to whatever makes sense. And you don't rely on mock tests or on just a subset of your application. You rely on what your application is actually looks like. And you see that all the other environment, your network, your infrastructure, all the data you are gathering from those environments are coming from production. Do you imagine analyzing your operating system in your test environment and rely on that to protect your production environment? That makes no sense. So you will actually check what is actually running in production and based on that, make a decision. But how can we do that? Well, we will just put the light in your application. We will deploy some sensor inside of your city, everywhere, on all the assets, on all the door, on all the locks. And with all of those sensors, we will create an AppSec graph. An AppSec graph is like the twin of your application, digital twin of your application. Everything that is happening inside of your application will be reported to the AppSec graph. And then imagine everything that you could do with this AppSec graph. You will have all the information that you need, all the libraries connection, all the connection with sub-application, everything that is important will be part of this graph. And then you just have to request the graph. That's all you have to do. Let me give you a bit of example on how would that work. And by the way, this technology is called ADR. Yes, we will add another DR inside of your vocabulary, application detection and response, because it's working exactly the same way it's working on all the rest of your environment. So let's go maybe a bit more into the technical stuff. I will give you an example of an untrusted deserialization. Untrusted deserialization, for those who don't know it, it's specific types of attack that could happen in some languages. Basically, it's a way to transfer an object from an application to another application. So you export your object as binary format and you upload it to another application. But when it's in the binary format, by definition, you don't know what is inside. So if you try to scan it with a WASP, for example, you won't see anything. If you scan your application with a DAST, you will see that it's doing some deserialization, but it's not an issue by itself. The issue is what is inside of the object you are loading. And here, the AppSec graph can give you an actual value. Why? Because we will inject a sensor inside of the deserialization library, which means we will actually see what is being deserialized. And then based on that, we can report that to the graph saying there is a specific library being deserialized at that moment that is absolutely not doing something wrong inside of the application, or in this case, it's actually killing the application. So we have to take a decision. And you have the ability then to block these attacks directly, report it to the SOC team and provide them all the information that they need from the graph, telling them that this object was doing this, but this application, by the way, is communicating with this very critical database. But that's just one thing we can do with the graph. But we can also help the developers during the graph. By requesting some information from the graph, we can also detect that there is misusage of a specific data. If we take the example of a SQL injection is very simple to explain. It's data coming from the user going to the database without sanitization. Well, let's just request that to the graph. And the graph will just give us the information from the production environment of all the requests that are coming from the user going to the database without sanitization. That's maybe not an attack, but that's a vulnerability for sure. And again, we will provide them all the information to the developers first to understand what is the issue, what they need to do. But also, we will be able to give them the vision of what happened in the production environment, saying that this actual vulnerability is actively exploited. Because we have seen some requests that definitely don't look legitimate touching this specific part of your application. And we can even tell you where that comes from. That's just a few examples of what we can do with a graph. And it's still dating and we will continue. But what is really important is that we have the ability to create this graph with a production instrumentation. And that what you need to remember is the ability that ADR can provide with this vision of the production environment.
Sure, thanks, Aurélien. So what we're doing with this technology, ADR, this is still very much early adopter technology. So we're still figuring a lot out, but it's out there and we're running a lot of tests. And this is data. We now publish a monthly blog on this. And what we've done, we've looked at all our customer data and we're analyzing it and we're thinking about it. And what we're seeing, and these are the statistics, that 426 million requests to dangerous functions, that is just simply an insane number. It's incomprehensible. And it actually means nothing. You're into the tyranny of large numbers at this point. Where it gets interesting is when we started looking at the 365,000 just slightly more curious security incidents. But again, if you're a developer, a SOC engineer, an AppSec engineer, good luck, because that's in a month. You just can't actually analyze that. It gets more and more interesting when you see the 4,000 probes. So then you know you're actually being targeted. So you're now into the world of threats and really begin to hone down how applications in production are being targeted. Then you see the 45 scripted, very advanced attacks. And on this particular month, this is from December of last year, it was deserialization. And these are the types of attacks which are going to bypass every form of defense you have at the moment, because our customers, like yourselves, are spending hundreds of millions of dollars on active defenses, but these attacks, these, crikey, these are some of the most sophisticated attacks in the world are getting through. And we saw 45 of them. That then turned into 5 particular incidents, which we could then block and then send that back to the development teams. We actually published some CVEs on it to actually then be fixed. And this is what we mean about context. On the left-hand side, that's just all noise. But could you imagine changing everything, flipping everything on its head? You now go back to the development teams and go, do you know that scan we gave you last month with the 3,000 vulnerabilities? Let's just put that to one side because I need you to fix these 5 pieces of code. And I can tell you why they need to be fixed, because we can actually show you how we're being attacked and we're only blocking them temporarily. So fix that code and do the fix permanently. And that's how we flip this game on its head. We stop the noise and get straight to the action. And suddenly you're now you're now into the whole DevOps cycle. No unplanned work, fast feedback loops, and more importantly, that trust which was destroyed back in 2005 with the big static analyzers between developers and AppSec, they're now going to start trusting you because the data you're giving them is that highly accurate, highly reliable, and it is crystal clear. There is no debate, you're under attack, do something about it. And that's how we're looking at ADR, it's flipping everything onto its head.
So, no, probably every one of you will say that, well, my organization will never let me do some tests in production. But that's not coming from us. That's from one of our customer. Remember that your customer are actually testing in production every day. That's where you have all the actual data. And that's where we need you. We need you to actually defend this vision of we need to actually detect the vulnerability and the attack in production, because that's where the actual data are. And actually today, it's more risky not to do that than actually putting contrast or any other ADR product. We are not here to pitch contrast, and there is plenty of other ADR competitor in the market. Try them. I won't tell you to take contrast, but take ADR technology and look what ADR can actually do, because that will really solve lots of your issues.
And just really then one very, very sort of final thought on all this, it's going right to back to the beginning. Where we are today is in a quagmire. We're not winning that particular battle. We do know that vulnerabilities are increasing, the fix rates are going down further and further, and we simply have to change. I was reading, actually on the train coming down, one of the great books on project management in IT. It's called The Mythical Man Month, and it was published in the 90s, and I think, and in that, and this is what you also have to bear in mind, this is early adopter technology, and in the Mythical Man Month, one of the key attributes is there is no silver bullet. ADR is not going to be the bullet which solves the application security problem. You still need fantastic architecture, secure architecture. What Gary McGraw was writing about in 1996 absolutely applies. In fact, we should probably get back to doing more of that, more threat modeling, more education, but we need to shift our emphasis away from potential vulnerabilities into those where you're being attacked, deal with everything right now, not in a theoretical construct. So those are the final thoughts. And Sam is looking at me very worried with a microphone. So, okay. Oh,
thank you. Questions. But because I got the microphone first, can I ask the first question? So my question to you, number one, is on the ADR technology and the way how, say, you talk about detecting and blocking attacks as they happen in real time in production. And Aurélien brought an example of SQL injection. My question is, if well, nowadays I see a lot of traffic on the internet that's happening all the time. A lot of people are using vulnerability scanners, which they just launch blindly, all the different URLs. A lot of them are actually being scanned by people like bug bounty hunters, trying to find the vulnerability and say, hey, I found vulnerability in this bug bounty. Thing is, a lot of it is, it looks like an attack, but if the application is not vulnerable, let's say if there is a payload coming to an application, which is protected by an ADR in real time, so it detects, for example, as a SQL injection payload, the application is not vulnerable, right? So what happens, and what is your kind of approach to understanding this? One thing is implementation, but the thing is it actually vulnerable?
Yep. What would define if your application is vulnerable? Usually it will be defined if this particular payload is actually going to what's called a sink. The sink is where the issue is. In the case of SQL injection, it's the database. All the other products that you're using today, like WAF, for example, would just rely on the payload because they don't understand what is after that. But as I told you, we put some sensor inside of your application, which means we will see what this payload become inside of your application. And we will see that in this particular case, that's a payload that looks suspicious, but this payload is actually touching the sink. So in this case, your application is not protecting itself, so we have to do it for you. But you're right, in 99.9% of the case, that won't happen because maybe that's an endpoint that is not even touching the database, or it is touching the database, but your application is already protecting itself. So in this case, we will see that it's not touching the sink, and we will report it, but we will report it with a specific status saying, just a guy playing with your application, nothing really interesting. And we will only focus you on maybe the 0.1% of the case where it's actually touching the sink. You should definitely have it.
And just to add to that, and to what Aurélien was saying, with ADR, there's always this temptation to say, right, an attack's coming in, and I know I've just been guilty, right, we're going to block it instantly. Pragmatically, how we behave as humans is that what we're going to do, we're going to see that coming in, and we're actually going to send it to the SOC to look at, because we still trust human judgment before we actually block it. So increasingly in those very, very extreme cases, that will probably go to the SOC for human review because people just trust that. And we would recommend that's what you do, and then the SOC can take that final action as well.
Thank you. Anyone with the microphone?
When you said like libraries, then we import the libraries. You said recently we can. So with these libraries, modified libraries or how do you?
So we really consider the application as a block. We work at the runtime. So whatever is representing your application, it will be part of the graph. So we will consider the application the same way it was if you would develop it manually part of your code, which means that we will have the ability to detect. And I had the case several times with some customer where the issue is not on their code directly, but in this particular case, the library used in this case will cause an issue. Most of the time it's because the documentation was not read properly, but that's the case. So that's another advantage that what I mentioned, we don't scan the ingredients of your application. We scan the result. We scan your application entirely, containing the libraries, the framework. We will analyze everything we present in your application exactly the same way. Yeah. We don't scan the application. We observe it. So by definition, we will just observe what is used. So, and that's why also it's important to be in production environment, because that's where you have the actual usage of your application. You don't rely on tests. So if a part of the library is never used, we will not report it. We will not analyze it. We will tell you that it's there, but you are not using it, so there is definitely no risk.
One question.
Okay.
This is just a follow-up question from this question. You said you observe the application. I want to understand, this is a behavior just for contrast or for all type of idea?
So ADR is really new in the market. So there is different vendor actually claiming to do some ADR, all with different kind of approach. We do it with something called instrumentation. It's a way to inject agent inside of the application. You have other ADR vendors that are doing the same way. And you are also some other ADR product which rely on eBPF. So eBPF, it's a way to instrument the kernel of your operating system. It's another approach. Give it a try.
Oh, our question again. Anyway, so from an AR perspective, what's the performance latency considerations?
So that's a very great question. Thank you. So of course, we live in the application, so we will cause some performance impact. I can just speak of the contrast impact, but it should be similar with all ADR technologies. The latency impact is minimal. We do our analysis in less than a millisecond. So it's even less than a watt. And another advantage, we do our analysis inside of the application. So there is no traffic going to a cloud for analysis and coming back. Everything is done inside of the application. So there we are even better. The impact that you can have will be on the resource consumption, which can be between 5 to 10% more resource consumption, but it really depends on your application. If it's a big monolith application, you won't even see it. You already have your the ability to get more resources, so that won't be an issue. In the case where you might have to do a bit of analysis, it's in Kubernetes or Docker environment where you actively restrict your resources. You might need to give us a bit more to be able to run. But in most cases, that's not a big issue.
And if I can just answer that very quickly, Simon, from a different perspective, there is a performance impact because there's no free lunch. However, there's a different way of looking at it. If you have 3 tiers of application in your business, tier 1, money maker, you're going to be throwing 80% of your AppSec budget at money makers because you're going to be using your SAST, your DAST, potentially ADR, you're throwing everything at it. I think the biggest use case for ADR is in your tier 2 and tier 3, where performance isn't going to be as critical, but do you know what? You get scanned once a year. The 0 day, which is in your tier 1 application, is also in your tier 2 and your tier 3. So as a bad guy, I'm going to attack your tier 2 and tier 3, get in there and move laterally across the organization because it is so easy. Reference SolarWinds. That's the basis of that attack. And I think this is going to be increasingly how we change risk posture in the organization. We take a more mature view and understand not all things are equal.
And since you mentioned free lunch show, we actually have free lunch. So thank you very much. We have some meetings over that and some free drinks, and we'll see you in about 10 minutes for the second talk. Thank you.
Brilliant. Thank you. You could not make up a better segue, Sam. I'm sorry. There we go.
Good.
Yes.
Good.
Okay.
Sophie's fallen off her horse.
Okay,
Dislocated her knee. I'm
Oh,
really
shit.
sorry.
No, James, go.
I've just been trying
Yep,
to
off you go.
persuade her. And
No, no.
She's very hospital and they don't want to go in and do
Yep.
stuff. I'm
Okay.
sorry.
Okay, we'll see. I hope she's okay. And
Yes.
see you
Yeah.
tomorrow.
Sorry about
Yeah.
that.
No, James, absolutely understood.
All right.
Absolutely understood. Do. Cheers. And things. Cool. Oh, is this this is such a cool idea. Hi. Thank you for the question. Yeah. Yes, yes, yeah. Yeah. Good. Yeah, I'm pleased you did. Oh, sorry, I do. Sorry, I wasn't actually getting those out on the phone. It's all right. So you're at the University of Aberdeen?
Yeah.
Yeah. How's that going? Yeah.
Going very well.
Yeah. Okay. Oh, wow. Okay. Good.
You mentioned something about sport.
Yeah, so I set up the Scotland OWASP group. It still operates. It's based out of Edinburgh. But what I would probably say is that I only set up the OWASP group because I was bored. I was in Edinburgh on Monday nights, nothing to do, nothing to do. So I just set up a group. There's one I wanted to do. Sorry. Part of our job, and all the other people who are on that.
So I'm on, I was, somehow or another, I was trying to access free Wi-Fi. I skipped the free Wi-Fi altogether.
And then you just enter your email address.
Yeah, it's that is the great thing about it. It starts. You don't have to do it every month. Just do it once every 3 months. Unless you go to OWASP.org, and more importantly, have Sam. I don't tell you how he started. They have power, and all they basically have started.
You'll use that table.
We don't have a clicker.
Wait, have a clicker? Yes, I do.
You know, I just got back on the road.
Absolutely fine.
Man,
Because
what
does
happens, man?
that.
You look excellent, man. Yeah.
I know everybody tells you that, but it's you definitely were on a.
Yeah, no, I got.
What happened? Sorry, was it a bad thing or good?
No,
Good.
good thing.
Oh, good. Because I once had to kind of say that because I get almost bad. Like, fuck.
No, nothing like that. I just basically at some point just got fed up, and so like my wife was with me for 3 months, like I always. And then I just went, you know what, it's gonna like because I gained and lost weight before and after, you know what, it's gonna hurt anyway, so just do it for 6 months and stick with it. But
Like Andrew Van der Star, tempting, Jim Manico, you know those guys? I'm sorry, who's this? Okay, he looked like Jim Manico. Oh, yes, yeah, in the past. So, and now, you know, but it's well. Yeah. Well, that's good.
so I'll show you some.
Yeah, you're not in a healthy stage, man.
So I have this Omron
Yeah.
scale that has body composition. And so on. So if I do this,
That you're not 71.
yeah, but
Wow.
that was from 112.
Wow.
So bear with me. So yeah. It's just like every now and then it updates. It needs to guide you through all this. Could you please stop it? Thank you.
Fucking hell, man.
This is from October.
There you
So
go,
from
man.
October I was 104. I'm now.
What you just do,
71.
just dead eating.
But this is the hardest thing, which is this is the
Hey, Aurélien, do you have your badge, by the way? Because I need to stick this in on me as well.
Oh, yeah.
Because it will be easy if we.
Oh.
If you, oh, you don't have
I don't have
that. Yeah, it's okay. It's a microphone.
Oh,
I'll
okay.
stick it on your ear.
Alright.
People online on YouTube see it.
Oh, okay. Cool.
Like that.
Yeah, sir. Does that work?
Hey, everyone. We're ready. There was an opportunity to finish up business at the end as well. Hopefully, and then we'll go.
Can I browse the web on yours? Can I browse the web on yours?
Yeah.
You just give me a tab. Oh, yeah. Yeah. Cool. You got this together around. Sorry. You know what I mean by that, right?
Yeah.
No. Cool.
Real time.
Should I close that one just in case? Your email?
No, this is personal.
No, I'll just close your email, right? Just
Yeah, close the email.
so that don't accidentally hit there. Right. Okay, cool. So I got my that. Got that. Okay, cool. Sweet.
Excellent. Okay, everyone, we're ready for our next talk. It's a great pleasure for me to introduce our next speaker because I am in application security. Actually, I'm in OWASP because of this person. I met Dinis many years ago. I think it's 2007, 2008. Dinis is one of the original founders of OWASP London.
London, yes.
As John has mentioned, 20 years ago in September 2004, Dinis, together in the pub and sent a mailing list post to OWASP London mailing list and saying, hey, we're going to have our first meeting. We're going to be in a pub and we're going to present 3 different talks. And Dinis is actually the first speaker and the first ever OWASP London Meetup in 2004. So fast forward 20 years, right? We're still here. And Dinis is still very much involved in application security. Those of you who do SaaS, right? You're probably aware of the product called IBM AppScan, which is HCL AppScan. But before that, it was called TubeScan.
No, never that.
And so Dinis is one of the founding fathers, not just OWASP, but SaaS technology as well. And if we go back, I think Dinis contributed to numerous OWASP projects. He served on OWASP global board for many years as well. But he also then became a CISO, various organizations, the whole Barrett, as CIO, CTO, security consultant, and financial services organization. Basically, Dinis, I can truly say, is one of the pioneers of application security. One of our legends. We're truly honored to have that. So we are very welcome.
Thanks. Sam always exaggerates a bit, right? Yeah, no, I was, I think the coolest thing is that I have been doing this for 20 years and I'm still as passionate. I still love it as beginning. And I still think it's a great industry to start with, right? I think a lot of industries, as they mature, they become very hard to get into. I think our industry, it's still very easy to get into. And if you're curious and if you want to learn and if you do stuff, it's really interesting. And I kind of share a little bit what you guys were saying about that recently felt like we were not moving a lot. Like I think we've been at AppSec for a while, for a long time, there wasn't a lot of innovation. Everything was kind of rinse and repeat. But I think there's a lot of great innovation, and especially around GenAI, I think there's a lot of great stuff that is flying around. So I'm going to cover some of that, especially the latest things I've been going into, which is all about graphs and semantic web and semantic graphs and GenAI and how to actually make the whole thing deterministic. So this is what we're going to talk about. I kind of have I had this idea that, and I when Sam, it's an interesting example. Like I feel like I'm now ridiculously productive in ways that I never did before, right? I know everybody talks about ChatGPT and LLMs and stuff, right? But if you're not really using it, like in a way that makes you productive, where you almost know when to use it, when not to use it. So for example, I don't have an LLM on my IDE, and I code every day, right? Just to give you an idea. But I use LLMs every day, right? So it was Sam comes to me and says, hey, do you want to present? And actually I was doing semantic web stuff. So I went to Sam and said, hey, Sam, what about this? And what I sent him was a 20-page document, I'm going to show you in a second, that was created with me. Actually, I think I was either walking the dog, I was cycling, I was just walking around, and I recorded a 15-minute debrief of my ideas. I went to ChatGPT, did research, and said, put this into a great research document. And he created an amazing document, right? The podcast that he talks about was actually created by Notebook LM, right? And then I said to Sam, what about this, right? And actually, it came out really well, because I think what I was able to crystallize was, in a way, what I think the future of OWASP needs to be and where we need to go. And OWASP, by the way, is an amazing organization, one of the best organizations in the world. I think it's a great, it's very welcoming. Again, it's all open source. You should be involved. You should be using to leverage your career. There's a lot of individuals here, me included, that we had jobs because of OWASP. We made friends because of OWASP. We have great relationships because of OWASP, right? It's still an amazing community out there. So I'm going to talk about using basically semantic knowledge graphs, right, around the OWASP content, right? So this is me. I've been for a year now. I've been doing a startup. It's really good. I love it, right? Highly recommend it, right? I think if you want to start a company, now is the best time ever to do it, regardless of what you hear, because there's a massive intersection of things that happens, right? That now is a great opportunity. And then talk to me if you have more ideas about it. So I'm doing this thing called the Cyber Boardroom, which is all about communicating and translating cybersecurity knowledge, because especially when I was a CISO, I realized that my biggest challenge was not to communicate with executives, was how to scale it, right? How to scale communication with board members, executives, peers, team members, colleagues, comms team, etc. So I'm kind of building the Cyber Boardroom to do that, to translate. And by the way, everything I'm showing here is open source. So I'm a chief scientist of a tech startup. I do a bunch of open source stuff, including a lot of stuff for OWASP. I also run the Open Security Summit, which is another really cool thing that we do. And what's interesting about my evolution, I highly recommend this, is I chose to become a CISO and basically on the exec very late in my career. And I highly recommend that, because by the time I got there, I was still very technical. I still felt that I still understood. And I would argue that I was able to make decisions, coordinate things, make stuff happen, because I understood very deeply, right? In a way, full stack in terms of development. Right. So GenAI, it's a massive opportunity. And actually, that's a thread. Sorry, I was just finishing the slides on the way here. And there's I actually did another presentation here in February, I think, right? Last year, when I talked about it. So if you want to see more about the opportunity and the thread, see that presentation. But I feel that, especially with the age of agentic AI, right? Like AppSec was never more important than what's going to happen now, right? What the crowd is doing with agentic AI is basically saying, hey, let's take these things that we don't know how it works, let's plug it to our internal organizations, let's remove all the AppSec and all the guardrails into it. Yeah, it's going to work, right? You're just about to see what's going to happen with that, right? So everything we do in AppSec is going to be needed times 10, right? The interesting thing about this, and this is, I have a question mark here, and we can go into more, is I'm not sure if it's the current generation of AppSec that is going to be the one that's going to solve the problem, right? Because the reality is that, if for the companies who adopt a new way of thinking, a new way of working, and the new semantic webs and the new way of using GenAI, you're going to be in a situation where a risk assessment company will do better AppSec than AppSec company, right? You're going to find that a QA tool, other industries will come in. And you know why they're going to come in? Because AppSec now really matters, Now, I think my hypothesis is that we actually going to be doing that to the others, because AppSec and cybersecurity, we have one thing that nobody else has, is that we are the only team in the whole company that speaks to everybody, has access to all the data. If you do the job right, it has relationships with everybody. So we can actually play this game quite interestingly, right? But see that presentation if you want to do. I also did a couple more presentations about the journey, the pipelines, and my non-functional requirements are the most important thing you guys can do. And I'll be publishing a lot of my deep research stuff. And I think there's some really cool stuff here, right? And for the people who think that you're very passionate about your ideas and you don't want to share your ideas and you worry that somebody's going to copy, well, I published a huge amount of intellectual property here, all for free. And and there's some traction, but not a lot. But my point is, right, this is really cool research, right? And I'm publishing some really good stuff. You guys should check it out. But a lot of this is also the work I do with ChatGPT, right? And I can scale now. I can communicate now in ways that I never could, right? So before I get into it, I want to do a very nice special mention to OpenCRE. If you guys don't know, it's an OWASP project, right? Yeah, it's a cool project that's trying to do this, right? A bit of the graphs I'm going to talk about. And they have some great linked information. So what they have is they have already gone to the point where they have a graphs. They got to the point where it's like, right, how do we use this? How do we actually get value from this thing, right? And actually, Petra's here, I know that's some crazy graphs we did in Jira, and others I think probably have seen that. I think I was addressing that problem there. Like a graph is not just for having a graph, you have to actually do some stuff with it. You have to connect the dots with it, right? Or else you have this. And this is pretty cool. So this is from OpenCRE, right? This is what graphs look like, right? If your graph doesn't look like this, you're not even playing, right? Because you don't have data. In fact, what usually the graph looks like is a gigantic freaking blob, right? It's like literally like, it looks like a dot. If you zoom in, is everything kind of in there because you have all these connections, right? And that's what you want. And I think the problem with a lot of existing graph databases and semantic graph is that they get there and it's like, yeah, now how do we do this and how do we maintain it? And I want to talk about the approach that I'm taking, which is a little bit different. You still have this, but I think is a lot more effective, right? So let's talk about what a semantic web looks like from an OWASP point of view. And I created the next batch of slides with the new ChatGPT 4.0 because I was playing around with it. And it's actually really cool because now it actually creates diagrams. It just about spells it right? So let me use them to explain this, what it is, right? So what if OWASP was a knowledge graph, right? So, and when I talk about graphs, it's node dimensions, right? It's relationships. This connects to that, connects to this, connects to that, right? And by the way, I did a presentation actually ages ago that I said, I think thinking in graphs, right, or something like that. And I realized most of my world I've been thinking in graphs, right? Source code is a graph, static analysis is a graph. I view everything as a graph. And then I go into worldly maps, which you guys haven't got into, you should do, because it's the only thing apart from GenAI that I've learned in the last 10 years that I think is really interesting. And worldly maps is graphs with context, which is really cool. But we can't even do that because we don't have the graphs. So we need the freaking graphs, right? So a graph is what? A graph is when you have connection, when you can go from one domain to another domain, and kind of things are hyperlinked. A bit like, the previous guys were talking about the AppSec graph, right? So what you want is you want to go from this sort of human readable stuff that we have today. And by the way, this is like a policy. I actually wrote a document where I says Europe should do this for all our data. I wrote one about legal. And like you can take anything you want, but because most of the content that we have is static, right? Is pages, is documents. And that's what a lot of people are finding when they try to put AI in the mix of all this stuff. They realize their data is not connected. It doesn't make sense, and then you have a massive problem. So, so what we want to do is we want to go from this sort of static content that exists in silos, right, to this sort of graphs and relationships. So we want to go from this world where you can customize the OWASP content. Because you see, the thing about this is that when you talk about a standard or you talk about a policy, right, you talk about a particular guidance, in a way, the elephant in the room is that you don't want just one version of it. You actually need 10, 50 versions. Like when you talk about, oh, we are PCI compliant, or we have ISO 27000, or we have GDPR XYZ, like you have to talk about in context, right? In a company, you're gonna have from legacy stuff to enterprise to cloud stuff to startup behaviors to people to systems who don't care to systems that you care about, and every one of them in a way needs a custom version of it. And OWASP has always struggled with this. And OWASP, is an example as a lot of others where we always struggle with this concept of, like, if you take even the top 10, ASDS, testing guide, all that stuff, is that You either provide so much material that is overwhelming. In fact, even the Cruz material is already overwhelming, right? But then even that is not constant specific, is not enough detail. But then if you make it very generic, then it's not specific, right? So you have these curves where you have stuff that almost falls into, it's like the anti-Goldilocks thing, right? You're actually not in a good space because you are too complex for what it's supposed to be, and you are too simple for the action. Because the reality is that if you want to drive behavior, if you want to drive change in a team, you have to tell them exactly what to do. And you have to tell them in context, with that language, with that technology, with that team, with that environment, with with the attack vector, etc. So that means that when we talk about, oh, I want to have an OWASP top 10 custom version, you need to have 50 of those, right? You need to have a custom version that is literally a mashup of OWASP top 10, ASVS, PCI standard, testing guide. And you know what's happened? Every single mature AppSec team that I know of build one of those, right? Because that's exactly the only sane thing to do. But it's all proprietary. They don't share it, and we don't evolve. But fundamentally, the key problem is that we don't have the data in a consumable way, right? And that's the problem, right? And that's what we need, because you need to be able to personalize it. So a lot of the work I do now is think about how do you personalize something. And what I realize is personalizing is not just saying, oh, make this connect to that person. Is you have to understand that person, their role, their knowledge, their culture, their language, how they want to be communicating, right? So I'm Portuguese. The way you communicate to a Portuguese is probably different than the way you communicate to a Brazilian. It's probably different than you communicate to a Sweden or to an American or to a Chinese or to an African or to an Eskimo, right? It doesn't matter, right? We're all different. We have different cultures. We have different references, right? And actually, the more you work in execs, the more you realize they really matter, right? And that's what I realized, that we need to bring that down all the way to our standards, to our communication, to our information. And you can only do that if everything is in the graph and on a semantic graph and knowledge graph. And that's very important. So what we want, so they are connected, not siloed, right? We need to have standard definitions so you can make sure that you can connect the dots. And by the way, this is a massive opportunity, right? Oh, I forgot to mention one thing. If you guys are looking for a business to start, I would do it here. I probably don't have the time for the next year or so to do it. So I hope somebody does it, because I think it's a really cool business. But I think there's a business here in building the semantic graphs, building the services, guiding companies to it. Because, and the driver is all these GenAI projects that are happening. They don't have good data. How do you get good data? You create some good graphs. And guess who understands graphs? The GenAI crowd, right? So it's a really cool thing. Yeah, so I would totally start a company around here. So how the LLMs do? So by the way, I'm very critical and I'm very excited about the LLMs, right? And it depends how you use it. If you use the LLMs to give you data, it's the wrong thing to do. If you try to customize an LLM, for me, I have massive allergic reactions. So anybody that talks about fine-tuning models, customizing models, models that learn, every single alarm bell that I have from cybersecurity rings, right? And a lot of the horror stories always start to happen. For me, models are commoditized. You bring your own data. You control the data. In fact, you control exactly what the model can do. And it's all about limiting what the models do. In fact, I wrote a cool article the other day where I basically asked the question, what is the only thing that the LLMs can do? And that's what you should use them for. Everything else should be code. Because actually code is still the most deterministic way to running something. What you can do is use the LLM to create the code or help you to create the code. But don't put the LLMs in line, right? I think that's very important. That's how I view it, right? So in this case, what I'm saying is that I don't want the LLM as an oracle, right? As, hey, here's the data, woohoo, 1 million context window. I bet none of you guys have any idea what that is, right? Even I don't think I know what it is, right? It's a lot, right? We barely do 100,000, if at all, right? Most of the stuff we do is like 10,000, 20,000, 50,000 characters, right? But yeah, you can shove all of it right in there, but it's still not the point, because you still don't have provenance. You still have this magic thing that kind of somehow explains. And I want to show you how I go around that. So I use the LLMs to extract the stuff so that we can take the PDFs, the static documents, and then filter it, personalize with semantic web, and then have dedicated use cases and personalized information, right? And I think what it means that the amazing materials that OWASP creates will be 10 times, 100 times, 1,000 times more valuable than they are today, right? Because that's the thing. And then we have a great tools. By the way, I open source this mGraphDB. It's a serverless Python graph database, because there was none out there who did what I need to do. So it's really cool. It's a file-based system graph database. and I'll take a look at it. There's the OWASP Spot, which, you know, Sam helped to nudge with again, a nice project, needs project leaders, right? If you want to help, you know, join me on that one. It's literally every work that I've done for the last couple of years, it's in there, including everything I did last year, right? And you know, and that's the thing. So that's the future, right? So eventually I go in here and I have this nice semantic web and everything connected to OWASP. So let's look at how this works in practice, right? Oh, by the way, you can read more here, on there. You know, there's the presentation, there's the documents, there's a podcast which I created using Notebook LM, which is really cool. So yeah, so I didn't create a podcast. I went to Notebook LM and say, hey, here's a document. And actually, it's a really good. I mean, if you heard it, right? It's actually really good. And it's on Spotify. You go to Spotify, you can hear it, right? But what I like about this, for me, this is me experimenting with this stuff, right? And it's really cool, actually. You know, like you go in there, you give the text, and you get a nice podcast on the back of it, right? And then there's this 20-page document that you. The thing about this is like, I actually think it's well written, right? You know, okay. What I like about this is that this is my ideas well explained. So this is the thing that I found interesting. I found interesting that I read this really well because in a way I know the ideas, right? But I find that, for example, I do some virtual consulting these days, and I come off a meeting with the team, and I literally do a brain dump, and I send them 10-page documents, right? Or 15-page documents. But they all get it because it's in context to what we talk about. But now creating documents is really easy, right? And that's very important how you communicate, right? So let's look at this in practice. So you got the top 10, which looks like this, which is amazing, has a lot of great content, but is literally markdown, right? And it's multilingual, but it's still markdown, right? So this doesn't really help, right? So what I've done was I built this API, right, which is now available, right? And what I can do with this is I have a way that I go and get the raw data. So this is the markdown, by the way. Then what I do is, and this is actually quite important, right? And this is a good example I was saying. So I wanted to convert the markdown to JSON, right? So yes, I could have built a parser, but what I did was I went to the LLM and said, hey, can you convert this to JSON, right? And one of the things I do these days with LLMs is that very rarely I get the text out of an LLM, right? These days I always give it a schema like this. So what I've done was I wrote this schema. In fact, I actually got Claude to write the schema for me, right? And you can see the schema has OWASP top 10. There's the OWASP factor, which is this article here. There's the text scenario, the reference, the CWEs, and the prevention. So you can see, in a way, this is a strongly typed. But this is an object, right? This already is a graph, right? This is a strongly typed version of this, right? So I go from here to here, see, all nicely JSON structured via this LLM call, right? So this is a good example of I'm using the LLM to accelerate my development. But this was very important, but in the end, there's still the human in the loop. There's still the verification, right? If there's a bug in here, I will pick it up, right? But the amount of time that it saves me, the structure that it's, in a way, it's a good example of the power of the LLMs, right? And this is what I mean that for me, the power of the GenAI is not in line. Is not as a black magic, oh, here's some stuff, give him some stuff back. Especially because remember that we still don't know how it works, right? Which is kind of interesting, right? We know that it works, but we still don't know, exactly how things are calculated, right? So we don't have provenance and extendability in the LLMs, right? So what you now need is an ontology, right? So actually, I didn't have time to map out, but I have another prompt that gives me an ontology, right? Now, the power of an ontology, this is another thing, Sam, that we need to spend some time on, is the ontology is almost the definition of what it is, right? This is where you say, let's say, I have access control, I have a user, right? I have, it's almost like these classes, these schemas of what we have and these kind of relationships. This connects to that, connects to this. So the ontology, it almost defines the space that you operate, right? And then from the ontology, you create a taxonomy. The taxonomy is the things that exist, right? In this case, is for example, the access control vulnerability, right? Or that you have here, right? Or an attack technique, etc. Right? And then what you do with this is you create the triples. So if anybody does the graph here, most graphs is based on triples, which is A connects to B via something, right? So depends how you call it. People call it subject, object, predicate. But basically, it's like user is managed by that user, attack application is vulnerable to attacks. Basically, it's the connections, it's the triplets, and from that you build all the graphics. What's cool about these triplets here is that these triplets are created using the ontology and the taxonomy that I defined before. And you can see it here. You can see that the subject has the value least privilege violation, which is an access control vulnerability. So that's the type. The type is the ontology. We're going to have a bunch of those, but in this case, we're going to have a least privilege violation, which is that particular taxonomy. And the thing that will be amazing for the OWASP is that we have 20 definitions of injection, right? We have 20 definitions of XYZ, and none that's wrong, but we need to connect them. So one of the things that I'm doing here, which is very interesting, is that I'm actually building one of these per OWASP top 10. So every OWASP top 10, A1, A2, A3, A4 has its own ontology, its own taxonomy, and its own triplet structure. What you then do is you connect them above so you can find it. Because what I realized that you cannot force people to have, if you try to create a unified ontology, which is what most people try to do, they go, yeah, let's do this. The first thing is, let's all agree on the terms, right? Now, 2 years later, or 5 years later, or 5 months later, or whatever, they're still arguing on the terms. And that doesn't work. In fact, I did with my team, right? I couldn't get my instance response team to agree on the terminology on Jira of the risk team and on those things. And then I realized that you don't have to, because with the graph, you can connect, right? That's the beauty of a graph. The beauty of a graph is you don't have to, each of you can have a freaking definition, right, of what vulnerability is, but there's going to be commonalities, and then we're going to find it. As long as you can create your definition on top of graphs, of relationships, we will find the commonalities, and then we can connect them, and then you can navigate them, right? So this is live. So yet to be continued. I'm going to keep putting on this, right? So let me show you now a practical example of this. So when in my startup, Cyber Boardroom, I've been published all the time. By the way, I release all the time. It's really powerful. It's really cool because I got a bunch of users, and I realized that I had the same curse that most startups have, that the users needed data in order to add value. The users have not added a lot of states. You get this chicken and the egg situation, right? And by the way, the other thing I've done, which I highly recommend, is I managed to run everywhere. So I solve lots and lots of deployment problems, which is great. So I can run everywhere from scratch, but I still have the same thing. Then I realized that cyber news feeds are a great example, because cyber news means that there always stuff happening, and you want to have your own personalized news feed, right? You want to have your own personalized data sets, right? What's going on today relevant to you? And I realized, oh, that's a great thing for the Cyber Boardroom, but let me actually build that first, right? And by the way, I'm looking for investment because now I figure it out, but I'm glad I didn't have investment 6 months ago when I did on my detour, right? So I'm going to show you this, and this I can explain in more detail because actually these slides are a little bit more mature than the other ones. So what I needed to do was, how can I go from this persona? So this is a description of a persona, and this is a cybersecurity, articles that exist. How do I go from there to here, right? So and this is available, by the way. It's on mvp.myfeeds.ai. You can get different newsletters for different use cases. So you have one for the CISO, one for the CTO, one for an investor, one for the board member. So and the idea is that I have all these news articles, right? And I want to create a customized version for a CISO, then I want a customized version for you, and then for you, and then for you, right? How do you do that, right? And more importantly, how do you do that without black magic, right? How do you do that with explainability, provenance, debuggability, right? That's the challenge, right? So here's what I did, right? By the way, there's some cool sites that you can go. That's the site that has all the information. Everything here is open source, right? This is a web page from a bunch of content from the user. That's all the news, and then that's the API, right? So you can go there, and I'll show the slides later today, right? So here we start here, right? So we start with this publish digest. So that's what you get in the end, right? So how basically do we go from here? So this is what the article looked like, right? So, and what you could see, I got a title, and then I have an image, right? That this was actually created manually with GPT-4o. Then I have a summary. I got the main areas in there, so you start to be more specific. And by the way, this will be unique for everyone. In fact, will be unique per person, right? So the CTO has one, the CFO, whatever persona I have will get a different version of these, right? Main topics, strategic implications, article details, and a link to the LLM, which we'll cover in a second. So this is the beginning of that. This is the beginning of saying, hey, I can personalize this massive amount of news that are coming your way, right? So let's look at these links here, because these links are very important, right? So what you got in these links, right? And this is the cool thing of open source, right? You can really make it really easy to access the data. And I'm using S3 as a database, well, a cloud storage as a database, which I get back in a second. So what you have here, you have three things which are very important. You have the actual cache of the request sent to the LLM. This is really powerful. So every request I make to the LLM, I save it. So I can go back, I can replay it. So I have a huge amount of performance gains from this, but also from the debugger point of view. So I save every single request that is sent to the LLM, right? I have saved the response, and I can even give you the prompt in a nice, easy way that you can copy and paste, right? So for example, what you have here is the system message. And by the way, if you haven't played a lot of this, I highly recommend. So this is the message that says you're a specialized news analyst creating news, right? Then you give it the schema, right? You the role. You then give it the persona description. You give it the article and the information here. So if I want to have a different persona, I just need to change this part, right? If I want to have a different view, I have that. In fact, this part here is the relationship between the article and the persona, and this is actually information about the article, right? So that's what I give to them, right? So for example, like if you want to create, in fact, I'm working with some CISOs, which is very cool. So they want to create personalized news feeds for their clients. So what they do is they take that prompt, and eventually I'll automate this better, but you can just take that prompt, feed it to ChatGPT or Claude, and then modify some, and you can get variations of it. It's really cool, right? And again, like it's actually, I found it's very powerful to also empower the users, right? You'll be surprised, like even those prompts are super powerful, right? So this is where it gets interesting now, right? So my response, and again, if you guys are doing anything with GenAI, I cannot stress enough how important it is to work with JSON and with classes, right? Because that brings a level of deterministic to the whole mix, which is insanely powerful. So what you see here is this LLM response that you got there, right, actually is created from this class, right? So this is the schema where you can see I got my persona, I got my executive summary, I got the digest, the section header, section text, and the article's IDs. So this is what I use to create the newsletter, right? So I don't go and say, hey, magically come up with a newsletter for me. I say, here's a schema that I want to use to do that. So the LLM then gives me the data that I can map out. There's the introduction, there's the section header, and there's the article there, right? So the data that I get from the LLM, which is this, feeds directly my schema. And what I've done was, again, open source, I have a little parser. And then Pydantics has the same thing, where you modify the schema, and then next request, the schema is now enforced, which is really cool. So I control what the LLM gives me by, in a way, the schema and the descriptions you give here, right? Which is crazy powerful. So think about it, like the LLM becomes a lot more resilient. The answer becomes, in a way, strongly typed on this, right? And so what you get, right, is basically, and if you look at, for example, here, the way this works, right? So you can see that schema that I showed you before. So this part here, if I now look at the cached entry, what you do is this is the definition that goes into the LLM. So the LLM, I say I have a persona type, I have a string, I have a description. So this description here is important because it goes here as a description, right? So this is basically executive summary, introduction. So this is the information that I give the LLM in order to get a strongly typed. And this is crazy. So it's powerful, right? Because I'm giving it a schema, right? So again, highly recommend. If you guys are doing any LLM stuff, don't get raw text and try to figure it out, right? Give it a schema and then play around with it, right? So this is what's happening here, right? So what you now see here is you can see that, for example, the response that I get, that text is the one I use here. That text goes here, that text goes here, right? So that's fundamentally, and then the article is the same thing. There's my headline, there's my article source, there's the image, etc. So this is the data that I then use. So in a way, this part here was created by that. So what's interesting about it is that I have very strong deterministic understanding by the creation of this, because I know that as long as my data is correctly here, that's going to come well here. So again, point is never asking them to give you HTML code. give it data that you can actually manipulate, right? And access, right? So that's what you have here, right? So, all right, but we haven't got the good bit, right? So how do we connect it, right? So how do we go from here, right, to here? Because you can see that here on my persona, so this is the one that is unique per person, right? I go fintech company, why it matters as a fintech system, right? So basically this is the same question as before, like how do you go from an OWASP standard into a customized version of it? How do you connect these two, right? So the way it works is the first thing I do, and this is very important, is I take the article and I create a semantic knowledge graph of that article. So basically what I do is I say, here's my prompt. You knowledge graph extractor for each of these, give me the relationships, and then I give it this schema, person entities, relationships, direct relationships, and I get this, right? So basically the first step is I go from content to graph. And the cool thing is the LLMs are very good at this because the LLMs are already kind of thinking graphs. So what I'm basically saying is saying, hey, instead of having just a blob of text, give me a graph that shows how the relationships in those texts actually map together, right? And in a way, this is crazy powerful because I can then use this to connect them. Like, so you can see here, there's my entities, there's my relationships, there's my schema, etc. Right? So again, that's the schema that I use, and this is what I get from the LLMs, right? Which is fundamentally, it's a graph, right? So what happens is I took this text, I converted to these entities, and I got that, right? So that is a graph that represents the relationships for a CEO, for example, right? The CTO looks a bit different, and there's different ways to present this, right? But that's how I then can know what I'm going to show to a CEO versus CTO, etc. And that's what we need. So the first step in our semantic web journey is to go from static content to semantic knowledge graph content. And this is everywhere. This is on your source codes. This is on your rules. This is on your marketing materials, on PDFs, documents, policies, everything. You have to move. We have to move from what is fundamentally static content into content that is mapped like this. And the coolest thing is that this doesn't need to be right? What it needs to be is good enough for us to go, oh, hold on, that relationship is not there. Like, Petra, like there's lots of relationships, like when we were looking at the Jira stuff that we only found when we saw it in the graph, right? There was lots of times that when I was creating these massive Jira graphs of the relationships amongst everything in the company, that is only when you can see the connections that we go, all right, that doesn't connect there, or that's not right. So what's cool about it, and I think the missing piece of the puzzle for the semantic web crowd, right, and even for OWASP, was we need the LLMs to help us to create this. Ironically, the better our graphs are, the less LLMs we need. So there's an interesting paradox here, which is actually the better our semantic graphs are, the less LLMs we need, because, and then the good thing, because we introduce less variability into the system, right? So, so let's zoom in, for example, on a couple of links. So how does it work? So this bit is that part of the graph, right? So now you can see that the reason why I have a note for mid-sized technology company is because the text tells mid-sized company, right? And I have a thing that says SOX and GDPR, and I extracted SOX GDPR. And I have business continuity, and I have that and that, right? So if you think about it, like immediately just here, I have provenance, I have explainability. I can say why that is there. And the coolest thing is we can now look and say, oh, there's nodes missing, there's nodes that are not relevant, there's relationships that need to be improved, and that's okay. And that's, again, why the human in the loop or human in the feedback loop is so important, right? So what you see here is basically that connection, right? So the CTO is same thing. There's the CTO graph. Here's the bits for the CTO. So you can see like different containerization, ML platforms, microservices, and they come from here. Cloud migration, ML platforms, microservice adoption, and etc. Right? So you can see that this is how I go from a persona into a semantic graph, and how I can then double check that everything is fine. Right? So that is the key piece of the puzzle, right? And that's what I was doing to OWASP content, right? So next step is we do the same thing for the article. So we take the article and we go, hey, can you extract from here into the schema, which is the entities, the direct relationships, the ecosystem, and etc. Right? So I feed an article to an LLM with this, and then I get something like that. So this is a graph for that content there. right? And this is actually without me even giving a direct ontology, right? Because, you know, that has the connections in there. So what I actually do is so you can see here, right? Like middleware is there, critical is there, vulnerability, is connected over there, right? So, so that's the flow, right? So, you know, for example, in fact, what I actually use the title and the description. I create two graphs, I merge them, and I create this one. So this is actually a simplified version of these two. I realized that it was kind of good enough, but you can see it, right? You can see that critical Next.js vulnerability allows attackers to bypass middle authentication. You got middleware attackers through vulnerability, etc. Next.js, you have the CVE, very important, etc. So this is the semantic graph for that article, and this is what we should have for everything. Every piece of content should have one of these. In fact, this should be part of an ontology. So this should be connected to our definition of attackers, our definition of critical vulnerability, which again is different for everybody, right, etc. Right? And that's how you can say, oh, but I don't use Next.js. Great, so this doesn't matter to you, right? So that's the power, right? So, and that's how the connection. You can see our transition checks go here, CV maps there, middleware request maps there, right? So here's the two other articles. So this one is for that one, ongoing cyber attacks exploit vulnerabilities in Cisco. You have Cisco, exploit, vulnerability, another CVE, smart licensing news, etc. Right now here I got command and control. You got Rosalind, Raspberry Robin, EC2 infrastructure, malware, cybersecurity, access broker, etc. So what you can start to see is that depending now on your interest, you can now easily filter these things, right? So now how do we connect the graph? So you can see, so I use one LLM to create the entities. I create the LLM for the persona, one for the articles. And actually, the way I do this, right, is I actually ask it, right? And actually, before I do that, I take this graph and I create a tree. So this tree view is basically that, right? You can see here, right? Those are the nodes in blue. That's the nodes. So that's the edges, and that's the nodes, right? Middleware, critical, Next.js. So that's that there. And then the edges, which is these relationships here, I represent as part of a tree. I actually found that this works really well, right? So the question was, in a way, like, how do I give this to an LLM, right? Because what I don't want to do is give it a screenshot, right? And actually, JSON was quite convoluted. I realized the tree structure actually worked really, really well. Again, the LLMs are actually quite clever, right? Understanding that kind of stuff, right? So that's what I do. So I feed them both, right, in this prompt. So you can see that's the prompt. So you are a cybersecurity knowledge graph. You're going to connect the two. I want you to match this. I'm going to give you the persona, and I'm going to give you the article tree. So that's the persona tree. That's the graph tree. So that's that one and that one, right? And then what I want you to do, based on this schema here, again, that's the connected entities. The most important thing is these two, persona entity and article entity. That's going to be the glue of two articles, right? So that means that the result that I get is something like this. You see emerging cyber threats middleware, and that means that I can now connect that on the persona graph with that on the article graph, right? Again, that's on the persona, that guy there, and that connects to that graph. So what you end up have is something like this. Here's my persona, regulatory compliance, who maps in this case to that there. Here's my emerging cyber threats, who maps to the middleware, right? And basically, you know, here's an example of the end-to-end, right? Here's my article. Here's my graph of my persona. Here's my graph of my article. Here's my graph. Here's my article itself, right? And that's the connection, right? Now, what's cool about this is what I have provenance and explainability, because, you know, some of you might already be thinking, well, that's probably not the best article to show a CEO, and I agree, actually, right? But what's cool about it is if this was a normal LLM, you have to go back to the prompts. You're going to fight the system. You actually didn't know why that was shown. You kind of go, well, it's not the best article, but you don't have a good explanation. Here, I do. I know exactly why, because I have this score, 7.5, that match regulatory compliance with critical vulnerability. That's probably not a very good match, right? Again, 7.5 probably was a good clue. I could calculate a filter like that. But that, in a way, is a nice way, right, to verify this. Like I said, the power of these workflows is I don't have to get it right. I have to get it so that we can then have feedback loops. And the persona can say, oh, look, let's create better nodes for my graph. Let's create better nodes for this. In fact, I would argue that the news organization should give me the graph already created instead of me having to create one for them, right? So there's a better example of that, right? So here you got regulatory compliance, regulatory bodies. That's a nice link. Right here, you've got business continuity planning, again, a nice strong link. And usually where things go wrong, and this might look simple, but in practice, it's a massive pain, is that's in lowercase, that's in uppercase, that's lowercase, this has an extra planning on it. When you try to do this, again, the LLMs are quite good at this. Without LLM, without the graphs, it becomes a nightmare, right? So in a way, I now connected much better this graph, right, for a CEO, like that one, or this graph for a CTO. Look, this is a great one. CD pipelines, GitHub Action, right? That's a really nice way to connect two graphs because, you know, they actually are equivalent, right? And ideally, these guys will have a common taxonomy, a common ontology, right? Which will give us even more assurance. But the coolest thing is if you do it like this, I know we have provenance, we have deterministic, right? We can explain. And I would argue that any GenAI project that doesn't have this kind of level of explainability, that's when you hit problems. And that's why there's so many projects that are not working very well at the moment. Because as soon as something goes wrong, they're going, oof, and especially the auditability of this is super critical. So because I use S3 as my database or cloud storage, because I can run this anywhere, every one of these steps leaves a file behind. So I can go back, right? And I can learn, I can see what actually happening. So that's very powerful. And by the way, this whole vibe coding, which is really cool. Right? I think the name is wrong, vibe coding, but I think it's crazy powerful because I think it's really empowering to allow, users to create tools and to be super powerful. But for example, in this case, I said, hey, can you create a UI to edit, for example, that prompt editor? And ChatGPT, Claude, and Lovable didn't really do it. And I was like, I'm not going to spend now, 4 hours here saying, yeah, fix it. Right? It's cool, right? But I still think that we are a bit far away. But what also I think it means that we now need to start creating applications that are easy to manipulate like this, are easy, have good architecture, so that these super powerful, vibe sort of, no code platforms can actually be used on top of it. What they need is good architecture, and that's what we should be providing on top of this, right? So finally, right? Oh, by the way, I'm about to finish. So yeah, so everything I'm doing at Cyber Boardroom is public business plan. I even have a nice box so you can talk about it, right? And yeah, and I'm looking for investments. Anybody wants to invest? Talk to me, right? But I have to say though, like even take a look at the stuff I've done here, because what I've done in here, and you get the link, is that I use ChatGPT Pro, right? And I wrote every single document for the investment pack, and then from there I created the business plan, and from there I created a pitch deck, right? But literally there's a huge amount, a lot of really cool ideas on it, and it's all open source, right? So you guys can reuse it, right? But I really feel that there's a great opportunity now to create companies like this one that are very lean. So the Cyber Boardroom costs, I spend more on coffee a month than it takes to cost, right? Because the costs are all passed to the customer, right? So I think there's a lot of power now in creating companies that do one thing very well. You find the users are happy, they pay you, but it's very critical that your tech stack doesn't cost you anything to run it. And this is much easier said than done. I actually spent 3 months to figure it out, but again, I open source it all, so you guys can copy it. But it's very important that you create platforms that are literally serverless, because there should be no state, and that actually forces you to really good decisions on it. And that was it.
So my first questions, this is a spotted case, you must be getting really good at prompt engineering. Because, well, I've noticed from slides, you figured out the prompts, how to get LLMs to take the unstructured data, or whose article in this case, right, convert it into a JSON without hallucinating. This is the question. How are you still getting the hallucinations? And then we managed to get it into the JSON in the right structure, in the right format. And because it's LLM and not a text parser, you've got things like uppercase, lowercase, different cases. But it's the prompts, right? Because there are marketplaces out there. People pay crazy amount of money for prompts. So the question is, A, how did you come up with the prompts? And B, are they open source? And can we see them?
Yeah. Well, okay, I think you had 3 questions in there, right? So the prompting, right, is first of all, by the way, some of those prompts were written by ChatGPT, right, itself, right? So ChatGPT, yeah, of course. Yeah, they write better prompts, right? Well, they're quite complete, right? The thing is not that, like, so for me, I use ChatGPT as a collaborator, right? So I'll give you an example. My workflow when I'm coding, right? In fact, if you go to my LinkedIn, there's a part of it where I have like all these documents that I created, right? So my workflow is like this. I say, even like the stuff I was doing for OWASP, right? So I go, okay, I want to do this. So I tend to use Claude for this, because Claude is just a little bit better, I think. ChatGPT, the latest ones are cool, but Claude, I quite like it, especially with the projects, because with the projects, you can give it the files. So I go to Claude, I literally have, like probably a half an hour conversation, right? And what I'm doing is I'm thinking better, I'm debating. So I'm not, you could say I'm prompting, but I'm talking, I'm writing my architecture. I'm exploring. I'm saying, what about this? What about that? Think about this. Think about that. And I'm guiding it in a particular direction. So, and that's what you guys need to do. You need to learn how to use the tools. Learn how it, in a way, how it's thinking, because it is thinking, right? It's not thinking the way we think, but it has a level of intelligence, right? I need to leverage it. So, for example, like a lot of that stuff, I tend to say, like, okay, now I need to do this. Can you write me the prompt to this? Or here's my prompt. Can you improve this prompt? So I view more as like I have conversations with the chatbots, right? And then multiple ones. And then again, you need to learn when to use ChatGPT, when to use ChatGPT Deep Research. And again, OpenAI deserves a prize for the worst naming convention that they come up with. But, play around with it, right? And then NVIDIA's and so the DeepSeek stuff and, like all of that is just, it's about having conversations and debates about it, right? And also being curious. What I like about it is like my learning now is so high, because everything I don't understand, I follow up, explain me this, I don't get this. So, and that's why I copy and paste to my code, because I don't have anything in the code that I have that I don't understand, right? Now, there's some area where, for example, writing tests is actually quite good. So I kind of view it as a lot of the code I get from Claude is like code I wrote a week ago, right? It's kind of code I could have written. It's a little bit familiar, but it's the same one as the code I wrote a week ago or a month ago, right? And then I take it and I manipulate it. But I found that having it in the IDE was actually distracting. So again, you need to learn when to unplug, right? On that. Now, the hallucination thing is actually, if you ask the LLMs to give you structured outputs, like JSON, so if you give it, it's called, basically they call it tool-based thing. So if I go to an LLM and say, here's the schema that I want you to reply on, in a way, is the stronger your schema, the less hallucinations you're going to get. And the other key part of the puzzle is that you want to give it data, right? So hallucination happens when you ask LLM to create data for you, to basically to go to this graph network and going, well, I think this. Where you get very little hallucination when you say, here's a text, right? Here's a schema. Now, for example, in this case, connect me this text to that schema. Like, for example, in that case, I have seen no case where I have a node that was not related to the text I gave, right? So for me, those are the hallucinations. So the hallucinations happens when you're trying to get the LLM to give you content. And you should never do that, because you don't know how, and the LLM cannot explain to you how the hell you give the content. So if you ask the LLM what's the latest OWASP top 10, probably going to get it wrong. But you say, here's the OWASP top 10, explain me the 1 and the 3rd, etc. Or here's the OWASP flagship projects, now tell me which ones are connected to X. Then it is a great job. So that's what I'm saying. If you give it content, right, and you have a strong schema, and then you validate it, what you get out, you get really, really solid results.
And one other thing that I noticed is, which is very important, when you're translating a very technical article about vulnerability to the CEO, you said why it matters. And I think it is what LLMs do best.
So for me, the big look, I literally would walk here like 3 years ago, right? As a CISO, and I would literally say, if you want to talk to me about AI, I'm out of it, right? Because I don't think nobody, even the people who claim to do it, they were not doing AI in the cybersecurity space. They might be doing a bit of machine learning, but I always felt that if you clean up the data, you can do a better job, etc. And then what you do. But when GenAI came along, that for me was like, now this is interesting, because GenAI has 2 things that I think are super powerful, right? The first one is, and this is how I visualize it works. So the GenAI, when people say it's only predicting the next word, fair enough, but it's predicting the next word based on a word model that it has created based on your prompt, right? That's why the GenAI translates very well, because GenAI will take a phrase that we have and will create literally a 20 or 1,000 dimensions graph with all the relationship. The problem is it doesn't know the difference what's true or not true, but it's very powerful then to translate it. That's why you can go from one language to another. That's why you can go from one persona to another persona, because that's all the word models that it creates. So I even took it further. So I did these things where I had like a cybersecurity sarcastic answer, right? It's like, hey, welcome to another episode of Let's Try Not to Get Hacked Today, right? Or freaking cybersecurity, blah, blah, blah. Or like I have this thing in the cyber boardroom where you can talk to 3 different execs. You have the CFO that says, show me the money, what's the thing? I just want facts. What, bottom line, you have the CTO, maybe a bit more friendly, and you have another exec who doesn't like the other one, who's completely sarcastic about security, thinks it's a massive waste of space. So it's actually really cool to simulate, okay, if I'm going with this message to them, like some of the dashboards these guys have, like if you go to them with your dashboard, like they literally go, what the heck is this, right? So I start to think about how creating a persona that represents that person, so that when I give it, like, for example, a cybersecurity briefing, from the other side, I can get something that an MBA expert or an accountant or somebody who's an expert in retail versus expert in financial industry versus expert in technology versus XYZ. So you start to think about their person and their culture, because the culture is also important, right? And also their state. Do they care? They're RASI, and these are things that if you give to the LLM, it actually gives you really good results, because you're just saying, act like this persona, right? So, and that for me is the power here, and this is one of the things I'm experimenting, which is that, and actually a lot of the vendors still fall for this problem, is that even you, like when you communicate with somebody, you have to imagine that if I give something to Vina, right, and I'm actually giving him a problem, even if I'm giving him a solution, because he now is going to have to translate to his team, he's going to translate to his boss, translate to the other stakeholders. So he now has 5 or 25 stakeholders that need to get the message that I just gave him. And he's going to have to translate that message, and now depends if does he have the time, the knowledge, the inclination. Well, it would be much better if I gave him 25 versions of it, right? And that's what I'm doing with the cybersecurity news feeds. I'm basically saying, I'm not just giving the CISO the news feeds, I'm giving the feed for him, for his boss, for the briefing, for the comms team, for like 10 different personas, so that he can then distribute it. And then we immediately communicate so much better, right? And then the quality of your personas matter, because the better your definition of that persona is, the more you can customize the message and the more you can communicate. From the person that wants one word, the person that wants a slide, the person that wants a picture, the person that wants a paragraph, the person that wants 20 pictures, right? It's all about customizing to them and delivering all of that.
Okay, questions? Yeah. Everywhere. Let me go. That's perfect.
Just gonna throw it in there, since we're on the Dinis phrasing, right? This is probably the person that is not fully responsible, but partially responsible for me being in cybersecurity where I am today. So thanks for that to Dinis. So I wanted to ask you a technical question. You're creating a bunch of these JSONs, which I'm also using now. I love graphs. I love how they connect to each other. You can throw S-bombs in it to give more context to that newsfeed. You can, then curate your content. How do you get users to then later have the ability to query that data somehow? And the other question is, have you considered actually pushing all that to a data lake, like Redshift?
Yeah. So yeah, so the first one is absolutely right. So the user feedback loop is a massive critical part of the system, right? So that I think you have, there's 2 layers here. I think there's the layer of we need to come up with interfaces and experiences that make the feedback loop very, very efficient, right? So it shouldn't feel like a massive thing for the user. But then you also have the kind of user, which I think is more the more power user, that I would argue that it's a very graph-driven experience, right? Like you visualize the graphs, and then it's almost like you're pruning the graph, like you're pruning your tree, right? You're making connections, you're figuring out the taxonomies and ontologies, and then you run it. But yeah, but that editing experience, the feedback experience is absolutely critical, right? So that's the one. And the other one, yeah, look, I think there's a lot of value in Redshift, in Neo4j, you know, like, you know, Neptune, large graph databases. I don't like when they are the data source, right? Because once and it's kind of like the LLM. So if you think about it, most databases, especially LLMs, is they like a dish that you're cooking that you can only add things. You cannot take anything out, because once you add it, you don't know. It's like a dish, right? Like the food has gone everywhere, right? So the LLMs and the graph databases are the same thing. Once you add stuff to it, it becomes this blob, right? This kind of thing, and that's why most graph databases eventually nobody can touch it. Very, very kind of curated, right? Because or else you can cause a lot of damage. So
then you use the LLM to query that data.
Yeah.
To create queries.
Yeah, but that querying is a little bit different, right? But the thing about the querying, what I found is that it's actually what works really well is you create these transformations. So again, there is power. There's some use cases where yes, you want to pump it to a massive database and query, right? But what I found that if you do this transformation, you leave them behind. That's what you want to query. So what you guys haven't seen there is that on that, in fact, you know, very, very quickly, what you have here, if I show you, for example, a persona here, and I have a UI for this, but I actually want to show you this part here, right? Is that if you look at this, right, what you see here is you see a description and you see all these files. See that? That's a file, digest HTML, entities, etc. So each of these, in a way, is like almost a database, not the PNG, of course, but they are a mini database. So what I'm doing is I'm almost creating files of files of files, schemas of schemas of schemas, and each of them zoom in a bit more, right? And I'm using the file system as my database. So what I have here is that the workflow that creates sorry, guys. So the workflow that creates actually you don't see here's on the admin. Sorry, I have a whole workflow that basically has 7 steps, and every step creates a different S3 file, right? And by S3 I mean cloud storage, right? Because it works anywhere. I use a local stack, which is really cool. So, but the power here is that, you know, what I found is that if you start thinking in terms of schemas of transformations, it actually the data gets cleaned up quite nicely, and then you query on top of that. Do you know what I mean? So it's almost like it's the same thing that we do in big databases, but you don't need to query the data all the time. And the power of a graph, if you think about it, the power of a graph is that you can have a huge amount of data sets, but you're just loading up the bit they're navigating to, right? So the idea here is that imagine like you have even complex queries, you almost load the data on demand, right? Which is kind of what the database are doing anyway. But if you leave these structures behind, then it scales a lot more, right? The only exception is if you're talking about things that have millions and billions of data points, then yeah, then pump it into, and that's what they do that, right? And that's why I like, ironically, you know, we built a great graph database on top of Jira because Jira, the nodes in Jira are actually very good, right? Because they have version control, they have workflows, they have, you know, properties, you know, IDs, they have links with each other, so it becomes super powerful. But the thing that I'm doing here is basically that ability to basically, in fact, you know, like if you look, this page here is fundamentally a page created from all of those files. So that file that you just saw there came from S3, right? So the other thing I found here, and I cannot, you know, literally I cannot understand how powerful this is the fact that, you know, a lot of the stuff that I'm doing here is basically stuff that I do, I pay the cost once to create the things, right? Like for example, the digest. Let me just find here the digest article HTML page, right? So this page here, which you saw on the other one, basically everything that you see here has already been pre-generated, right? So here's all the entities, here's all the information. So again, if I want to say for this article, where are my entities, right? I can see them here, right? And I can basically start to see the connections, right? Between one and the other, right? And And the power of this is that, in a way, a lot of the stuff that I do here, it's a one-off cost, right? You create once and you save it. Create, save. And the reads are then ridiculously fast, right? So the thing about this is, if you think about it, my graphs are not necessarily just the nodes and edges, right? In fact, this guy here was created using the M graph that I bring in, because this is me bringing JSON into a nodes and edge kind of structure, and then I build an export that allows me to say for each of these color code a little bit differently, right? So basically the way I think about this is, my graph is not just the nodes and edges. My graph is made of nodes and edges and a JSON file, and I connect here, and I go over there, and I go here, right? And it's almost like the relationships, right? And that's the power of it. So the graph, in a way, is almost like, as long as I can connect to something, that's now a path in my graph. Sorry, a bit long.
Did you have a question?
Yeah, I just want to ask a question in relation to what you said regarding the payload.
Yeah.
If you're using LMM and using machine learning, I know you can edit the pseudocode. Now, but with the code injectors now, how can you harden your LMM not to, because people can inject code to make the API or the chat box or the chat GPT or whatever to behave in a way that they can sneak in RCE, reverse code execution.
Yeah.
Is there any way where you can block that backdoor in terms of future of AI?
Well,
As
so
like
yeah.
somebody committing suicide with the AI, they inject malicious script, and then the person can tell them, well, you can commit suicide and stuff, and it's happening in the US, which is very ethical.
I think that's going to be a massive shit show, right? And by the way, if anybody here is onto offensive security, like you should have me feel that, right? Because I don't think we have even reached the buffer overflow stage of our LLMs, right? There's a time where, you know, Microsoft had a great picture, right, on SDL, where they have a string safe, right? That was called string face because he had a try catch, right? And it was literally memory copy, right? It was like buffer overflow 101, right? I don't even got there. I think we're going to get to the stage where people are going to be able to put payloads, they're going to be able to talk to the LLMs in ways that we don't even understand, right? Because again, remember, we don't understand how they operate, right? I think that there's some crazy cases now where people putting payloads on the web, they wait for the LLM to harvest that data, and then they become weaponized. And why? Because we don't know how the LLM learned, right? So the way, and I see some crazy cases with agentic, what they're actually doing is they're saying, hey, can the LLM write some Python code that I then run on an interpreter over here to get some results? Like, what can go wrong on that stuff, right? So I think it's about how you architecture your stuff. And the other thing you should all be doing here is that there's this really cool concept of triple redundancy checks, right? Which, for example, the divers use and other people use. So, for example, like if you're diving to a lot of depths, you either bring one watch or three, right? Because if you bring two, but diving means if you go very deep, right, you have to be careful going up, right, or else you can die. So if you have two, depth watches, right, if they don't match, which one's right? So if you have three, the possibility that three of them fail at the same time is very, very low, right? So it's the same thing with LLM. So if you think about it, you asking about deterministic, literally the more LLMs run in parallel, the more sure we are of the results. Because I've done things where I run 3 and 5 in parallel, and then I compare the results. Not necessarily to judge them, but to go, do they agree on this? Because if they disagree, for me, there's probably something a bit off that I might want to rethink a bit. So if you start to think of, again, as the LLMs, as they become more commodity, that you run them in parallel, and then again, leave that behind so you can go back and analyze what happened. I think that's how you prevent that stuff, right? But I think we have not even seen anywhere close the kind of exploits that are going to happen with LLMs on this. Yeah.
There will be more.
Oh yeah, it's not, we haven't even seen it, right? But to be honest, that's why there's a lot of projects that, when you hear that only 10% of the projects go into production, right? Why do you think that is? Because they do QA tests and then go, oof. Like, oh, we can't have that, right? Because the other thing, there's a great article from Bruce Schneier, right, who talks about the interesting thing about the LLMs. And I think it's crazy powerful when you use them to do stuff like this. But the other problem with LLMs, they fail in very different ways, right? Like, for example, most of our systems, they tend to fail unless there's a very odd bug that never picked it up. It's kind of more predictable, right? Like good code, It's very robust. Bad code tends to fail all the time. You know, there's a lot of stuff here. The LLMs have these crazy properties that they can be great, and then they fail dramatically, right? It's not like a little bit, right? And none of our systems are prepared for that, right? I'm still waiting for the ones that literally blow up half a company or delete data that they can't restore because they haven't realized that most databases have no state. They don't, you know, you override stuff on top of the other. So can you imagine what happens when the LLM makes 25 changes and you go, shit, they're wrong. Can you revert? Well, we can revert the database the way it was a day ago. I was like, can you revert those 25, right? So I think that those guardrails we don't have them, right, in place. And most of what we got away because our apps didn't do a lot of damage. But now that you're plugging that through, and that's why we need AppSec, because guess what? We in AppSec care about those things, right? Threat model is all about, you know, I wonder what can go wrong, right? So great place to be AppSec, so, and OWASP.
That's a question. My question was around Semantic.
Yeah.
It looks like there's only one real dimension there, which is like he works with who?
Mm-hmm.
Are there any other dimensions you've got as far as your thoughts? What people like, what style that they what I care about versus
Yeah. Yeah, so the coolest thing is that that's now the ontology and taxonomy that we get to define. So that is literally about the prompt that you put in, right? And I think what's going to happen in the medium term is that you start to have the persona in itself is not just a text, it's like a graph, right? And that graph can have all those angles. And then you can choose whether you want to have more or less. So it's not like just a dial. It's almost like how deep your graph wants to be, right? Even culturally, right? Now, how deep you want that information to go. So yeah, I think there's some cool research to do, even to do that in 3D, right? The thing about, so the reason I like these static images, and I have to say that I don't understand why a lot more people don't do this, because you know when you go into the RCE and you get all those graphs you can move, right? As soon as you move a graph, like, well, I want to go back to that place, right? And also, like, if you have to navigate through, every one of those is a non-deterministic step. So what I like about static images is I can think about what I want. What's my outcome? What is my objective? How do I want to represent things, right? And so I found it powerful to be able to, for example, so, and by the way, if you guys go here on the site or the MVP, there's this area here that talks about how it works in detail. So what I want to show you very quickly is that I needed to answer a simple question, which was what articles are recent and what articles are not recent, right? So what I did is I basically created a graph specific for the timeline. And this is kind of go, Petra, a little bit to your example, like things like that. These days, I'm going to create a graph that represents what I want to do, and I'm going to visualize it. I'm just going to navigate the graph, right? Because when you do stuff like this, actually the graphs help a lot, right? So here, so this goes into more details, right? But what's cool about this guy here, I think is this one, is that it might be the sorry, it's a long article. I think it might be the first one. Yeah, so it's this one here. So that's the one, but I want to show them side by side. So what you have there is a graph that is created there. Okay, right? So what you have here is a graph where every one of those is an article, and that's the date, right? So I know that this one was published on the 11th hour of the 14th day of the month 3 of 2025. Right? And in fact, you can see here that this guy goes up to 19, etc., and this starts on 19. So you're actually going to see that these two blocks are the same, those blocks are the same, 17 got cut off there. So that's before, and then that's after, right? But that's in a way, that's the power of, with the graph role that I go now. I arrive here by exploration. So I arrive here by the programmatic way of the M graph, where I start to go, well, actually, I have a date. So I created all these nodes for the dates, but then I go, but I can reuse them here. So I reuse the node, I don't reuse it. So it's more about the question that you want to ask. So going back to your point, I think eventually we're going to see a bunch of different ones that represent the different personas And the whole point of it is to have explainability, to be able to say, that's how I arrived at that decision. But this is now very effective. I think it should be golden on instant response. Can you imagine this on instant response? Where every single activity, you have a little thingy and you can navigate and you can know exactly what happened when, occurred. But so what usually happens on database is you pop all of it into a database and then you try to query and make sense out of it. Where I prefer, so here, I then use this to go into my other graph. So it's almost like this becomes the timeline graph that I'm using to answer timeline-specific questions, right? And it can live in its own files, in its own structure, in its own mgraph databases or JSON files, and I can just load and consume it on demand.
So are you telling me that I can get my CRO?
Yeah, exactly. Or you want that. Okay, that's fine. I once did one where I was having as a Brazilian football commentator. I don't know if you ever heard those. They're hilarious. It was really cool, right? Like, you read, the cybersecurity events or data as, a commentator of football or, whatever sport you're into.
Wonderful. Let's all thank Dinis for